This is a demonstration of Sodick IntelliQvic importing a 3D solid model. This will be for the die shape example, 4-axis die sample. Here's our operating interface. First step is to import the model. We will go to the model selection at the bottom and hit the folder icon. And we have parasolid type XT you could import or XB. And the file I'm looking for is the fourth sample part, that's XB. And here's our example model. So it's basically the little 4-axis shapes, basically a little circle in the center, and then there's these kind of ears on the top that blend down, I should say, down into that bottom U shape at the bottom. Put it in ISO view here and configure it like this. Okay. So first step here would be to go into feature recognition, contour extraction, and it finds the model is 1.18 inches thick. And for our extraction, we can leave it on all, which it'll find the outside shape, which is okay. Or you could say die, and it'll just find this inside shape, which would work fine. We'll put on all just to show you what that happens, what it does. So it finds the inner shape and the outer shape. The inner shape, it lists them here in the bottom left, what it found. It found this TB different, which is 4-axis. It's 10 elements. That's the green one right now on the screen. And then it found the contoured 2-axis. This is going to be your punch shape. Let's see if this slides over. So you got your 2-axis punch shape. If you were going to cut the outside shape, to cut it out of a block, square block or something, it finds the outer shape too. So we won't end up necessarily needing to program that, but that's what happens when you leave this on all. It'll find all the inners and all the outers. So we could delete this one if we don't need it right now, but it's okay if it's there. It's not going to give us a problem, because you'll see on the next page we would have to turn it on to program it. So before we go onto the programming page, I need to put a start hole. Let me put this in a top view. We need to put a 2D drawing and put a starting hole. And I'm going to put it at 0, 0 here. Draws in my little white start hole. Next step is machining path generation. And you can see here's my two features listed. The 4-axis one, die, and 2-axis punch. So the first one is check mark just because that's at the top of the list. If I wanted to program one or the other, I can put a check mark here, which one I want to program. So I'm going to do the 2-axis die first. And I'm going to pick automatic. No, I'm going to leave automatic off this time, so I'll show you what that does. Then we will do generate path. Pick our power settings. So this is set right now for 1.18 inches thick. Maybe the flush cups are going to be open top and bottom. And I'll make 3-pass technology. I'll leave it on this rougher finish, so it's 3-pass. You have finer finish possibilities with the ALN machine, then you have a 7-pass technology too. But I'll just leave it on the 3-pass technology. It doesn't really matter for this example. We'll put in here our glue tab size to hold the slug in place, the cutoff, and an avoidance. I'll maybe this a little bit bigger just so make sure it shows up on the screen. And our lead-in will be a straight lead-in line. Instead of these, you have the arc ones where you can come in with a blend if you want to come out a blend radius. But for this example, we'll leave that straight. Hit OK. So now we have, in this example, it's I didn't have it on automatic generation. So what it's asking for me for here is at the bottom left to specify the starting hole. So I got to click that circle we made before. And now it says click the entry element. So on the circle, or on the shape that you want to cut, you've got to click on something. See how this highlights on little flat that's lit up. Now I'm on the circle. That light, when I move the mouse around, it lights up stuff that I could click on. So I could click on the circle. I'll light that up. And that's where it goes to for the lead-in line. And it's completed. Here's our little glue tab up here, the tab width and the avoidance distance right there. So next step is to, and here's how the 4-ax blended in. You know, it found all the elements from the surfaces, top to bottom, the way it was made and the solid model was made. Follows what's there. Next step is to create the NC code, convert to NC, put a name in here, sample, let's call it 4, and hit convert button. Now there's convert parameters here. What that allows you to do is go into here and you have your stop codes. If you don't want to have the stop codes, you can always say no to the stop codes or change them into MO1s. If you want to be able to switch it on and off at the controller with an MO1 while you're running, you can turn MO1s on and off. There's a button for that. Or if you physically want to make sure it stops, or if you want to have a slash M, you have some choices on how you want to stop. And after the cutoff, so what that means is it's going to rough cut. When it goes to cut it off, you want that extra stop where you would pull the slug out. You could say no, or yeah, give me another M00 there too, possibly. Okay, and it's set up for the move to first starting hole. So what this does gives you a G00 to the first, to move you to the starting hole. If you don't have this check marked, you're going to get a G92 of the X and Y coordinates of the start hole versus move to the starting hole. And we're going to output this in a single coordinate system, G54. And I'm going to hit convert. So that'll make my NC code for me. Now, if you were at the machine, what you would do is hit the graph, you'd be in the edit page, you'd move over to the edit page, and you'd be looking at the ISO or G-code program. You hit the draw button to graphic it, but we're at the PC here. So what we're going to do is exit out of here, and in my folder on my hard drive here is sample 4 now, just created right now. That's the program we just made. Here's your 3 power EPACs, or C codes we call them. MITS calls them EPACs. That's the power setting for the 3 cuts. And here's your H codes, 1, 2, 3 for the wire compensation. And then again, here's your decode program, ISO program, like a Charmy calls an ISO programs. Charmy, this would be your tech file up in the top, and then you have your ISO down below. We kind of combine it all into one for a Sodick, and then also note it's a 4-axis program, and we use true geometry, true GO3 circle interpolation, GO3, GO2 codes for 4-axis, meaning it's all your circles are not broke up into line segments. They're all true geometry. And you can see here each block of code to do the shape is broke up with a colon. So you can see there's, what is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 blocks of code to cut that shape. So that's quick demonstration of for a die cut.